basically cutting him off and usurping his position. For the interrupting male, this creates an opportunity for mating, but it also requires more effort than pursuing another female that's not attended by a rival. And then for the rival male, it involves the loss of a mating opportunity. I previously found that males direct significantly fewer interruptions towards their positive relatives, towards rivals that they're more closely related to, and in sort of this graded manner shown here. And if we think about neutral relatives, which are in the middle as sort of a baseline, this means that males are avoiding competition with their positive relatives, and then going out of their way to compete more with their negative relatives. But in order to know whether or not this constitutes altruism and spite, respectively, we need to know something about the fitness consequences for both a male and his rivals. And that's the goal of the study that I'm presenting. So to measure these fitness effects, I created replicate social groups in the lab with males that varied in their relatedness. And each group included 3 males and 5 females in order to mimic natural sex ratios. 1 male in each group was a focal, and I observed his competitive interactions with his rivals and ultimately the reproductive success of both him and his rivals. One possible way to create variation in male relatedness would be to manipulate their genetic similarity, their G, with one another. But a problem with this approach is that we would expect all males involved, including the rival and his focals, to respond accordingly. And this could obscure the fitness effects involved. So for example, if the focal male is behaving altruistically, but is also the recipient of altruism, we might not be able to detect the personal fitness costs of that altruistic behavior. So instead, I developed an approach to decouple the responses of the focal and rivals from males from one another. And I did this by exploiting the way that guppies recognize their kin. So I previously found that guppies recognize their kin based on similarity in terms of their olfactory phenotypes. And this appears to involve individuals acquiring information about the population distribution of phenotypes within their rearing group, as well as where their own phenotype falls within this distribution. Conspecifics that are more phenotypically similar than average are perceived to be positive relatives, so more genetically similar than average. And conspecifics that are less phenotypically similar than average are perceived to be negative relatives, so less genetically similar than average. And what this means is that I can alter the distribution of phenotypes that focal males are experiencing during development to manipulate their perceived relatedness to their rivals. And I did this by rearing focal males in 1 of 3 treatments, which were each a different distribution of genetic similarity between the focal male and his rearing associates. Rival males were always half siblings, so G of 0.25, and this meant that depending on the focal male's rearing treatment, those rivals should either be perceived as positive relatives, so more genetically similar than average, or as neutral relatives, or as negative relatives, so less genetically similar than average. And then rival males, in contrast, I reared separately and all in the same distribution such that they should always have perceived the focal male to be a neutral relative. And so basically what this approach is doing is it's creating these asymmetries in relatedness between the focal and rival males, allowing me to decouple their responses from one another. All right. So I've observed a total of 22 groups per treatment so far, and I'll start by showing you the results for how often the focal male directed interruptions towards his rivals in each treatment. So we can think of the neutral relatedness treatment as sort of a baseline here, and we see that focal males were directing significantly fewer interruptions towards their rivals when they were positive relatives, and significantly more interruptions towards their rivals when they were negative relatives. And so basically this result is showing that relatedness did modulate interruption behaviors in the directions that we expected. Turning now to interruptions performed by the rival males towards the focal, we found no significant differences between treatments. And this is a relief because it means that we have effectively decoupled the responses of the focal and rival males from one another. And so any fitness differences between treatments should be attributable to this kin discrimination by the focal male. Next, I'll show you the results for how often, for the reproductive fitness of the focal males in each treatment. So we can see that focal male fitness was maximized in the neutral relatedness treatment, which is when we expect them to be acting most selfishly. There was a subtle but significant loss of fitness when focal males were interacting with positive relatives, so when they were avoiding competition with their rivals. And then we also see a significant loss of fitness when they were interacting with negative relatives, so when the focals were going out of their way to compete more with their rivals. And so basically this result is showing that there is a significant personal fitness cost to this kin discrimination. And then turning now to rival fitness, we see that fitness was intermediate in the neutral relatedness treatment. There was a substantial increase in fitness when the rivals were positive relatives, so when the focals were competing with them less. And then rivals did much worse in the negative relatedness treatment when they were receiving more competitive interactions from the focal male. And so this result is showing that rival fitness is strongly affected by the competitive behaviors of the focal male. All right. So now, having measured the personal fitness costs of this indiscrimination and the fitness consequences for the recipients, we can plug these values into Hamilton's rule to ask whether or not they provide evidence of altruism and spite. So in other words, we want to know, are these personal fitness costs outweighed by the respective benefits multiplied by relatedness? And I'll show you this calculation first for interactions with positive relatives. So I've plugged in the benefit and relatedness here. The benefit has to be doubled because there were 2 rival males affected in each group. And so basically this top bar represents the indirect fitness effects of this indiscrimination, and the bottom bar represents the personal fitness costs. And as you can see, the indirect effects are outweighing the personal costs, meaning that selection should be favoring this strategy, and this is providing evidence that indeed this is an altruistic behavior. And then turning now to interactions with negative relatives, we can repeat the same procedure as before, only in this case the benefit is negative, so it's actually harm, and it's directed towards negative relatives, so rivals that are less genetically similar than average. And once again, we see that the indirect effects are outweighing the personal fitness costs. And so selection should be favoring this direction of greater competitive efforts towards negatively related rivals. And that means that this is an example of spite. And so I think there's sort of 2 take-home messages from these results. So first of all, testing for altruism and spite is normally difficult because the responses of individuals are usually tangled up with one another. But I've developed an approach that allows you to disentangle this by creating asymmetries in relatedness between individuals. And I think that this could be a useful experimental tool for future work in the field of kin selection. And then by applying this approach, I've managed to show evidence that guppies are indeed following a bro code. Some males are avoiding competition with their positive relatives and going out of their way to compete more with negative relatives. And selection appears to be favoring these strategies despite the fact that there are personal fitness costs involved. And so this is providing novel evidence of altruism and spite in the context of male-male competition. And one implication of this is that spite may be a more general phenomenon than was previously believed. All right. So with that, there's many people I want to thank, my lab mates in the Rod Lab and several others in the department at U of T. And this is for a combination of feedback on my talk and help maintaining my numerous fish. And I'm happy to take any of your questions. It appears to be separate, but one of the reasons we think it is important is because sneak population requires the male to get in close. So by interrupting, they basically give themselves opportunities to perform those sneak meetings.
I have a question about your fitness.
Yes.
So was that with a rival and it was like 2 males and 1 female, or how did you do the fitness part?
Right. So basically, this was the reproductive success of the focal male, measured across all the females that they were interacting with. And this was the average reproductive success between the 2 rival males that were present.
So were they just all in a big group tank?
They were all in a big group tank, yeah.
And then you genotyped all the babies?
So I actually, to make my life a little bit easier, I used males with distinctive color patterns, and because they're highly Y-linked and heritable, I could actually just look at the number of sons that were present. And so I used that to determine paternity. Okay. Oh, feedback, yeah.
So these definitions of spite and altruism, I'm just wondering, can you also, when you have altruism, when altruism is directed towards kin, can't that also be interpreted as some kind of spite because you're not directing resources to some non-kin member of the community?
Right.
I'm just saying, isn't that just a matter of definition?
Sort of. So yeah, so there has been, just really quickly, so there has been some theory suggesting that altruism and spite can be mathematically rearranged to show that they're the same thing. But what I think is interesting is that There are reasons why we expect the sort of behavioral mechanisms and ecological context that lead to altruism and spite. Those should be sort of different in nature, and so I still think it's useful to consider them separately. PhD student working with Helen Rod at the University of Toronto, and I'm going to be presenting some data from an experiment underway asking whether male guppies competing for mates display altruism and or spite towards their competitors. The natural world gives us many examples of social behaviors that are costly to the actor, reducing the relative fitness of the organism. And these include the sterile worker caste of eusocial insects, alarm calling and vigilance behaviors in spirids and birds, and cooperative breeding behaviors in a variety of taxa. And these behaviors are paradoxical under the classical view that selection should maximize organismal fitness. But Hamilton's inclusive fitness theory famously resolved this paradox. So selection acts on inclusive fitness, taking into account consequences for others in the population. And so a costly behavior can evolve if the cost to the actor, C, is outweighed by the benefit to the recipient, B, multiplied by relatedness to that recipient, which is R. And relatedness is crucial here because it describes the probability that the actor and recipient share copies of a given allele. So most of you are probably used to thinking of relatedness as the degree of recent common descent between individuals. So this would be 1 for twins, 0.5 for full siblings, and 0 for non-relatives, for example. But this is actually a measure known as consanguinity, or G. Relatedness itself, which is what matters for kin selection, is a measure of variation in consanguinity relative to the population average, and it can be calculated with the equation shown here. So a conspecific that's more genetically similar than average is a positive relative, and one that is less genetically similar is a negative relative. And so a cousin, for example, could be a positive or negative relative, depending on the population average consanguinity. Because relatedness can take on both positive and negative values, Hamilton's rule can be satisfied in two distinct ways. So first, if the benefit and relatedness are both sufficiently positive. So in other words, if individuals are helping their positive relatives at a cost to themselves, thereby increasing the overall frequency of the causal alleles. But Hamilton's rule can also be satisfied if the benefit and relatedness are both sufficiently negative. So in other words, if individuals are harming their negative relatives at a cost to themselves, and this can be selected for because it reduces the frequency of competing alleles. And this is something that's known as spite. Because kin selection theory has reformed the way that we think about selection, there has been much interest in searching the natural world for supporting examples. And evidence of altruism has proven both abundant and widespread, and this includes the many diverse examples that I outlined earlier. Evidence of spite, however, has remained lacking. So clear examples are provided by worker policing in eusocial hymenoptera, which basically involves workers killing their negative relatives by destroying them as eggs. And then also by bacteriocin production, which is basically a part of chemical warfare amongst different kin groups in many bacteria. But evidence of spite remains limited to these two groups, and so its generality, both taxonomically and ecologically, remains unclear and hotly contentious, with some even calling spite Hamilton's unproven theory. Several possible explanations for the rarity of spite have been suggested, but one additional possibility is that spite may just be difficult to detect. And an important obstacle is that it's often difficult to actually measure the fitness consequences of any particular social behavior to determine whether or not it qualifies as spite. So to help address this, I'm testing for altruism and spite in a system and behavioral context that I think lends itself to making these measurements, and that's male-male competition in the Trinidadian guppy. So guppies have a promiscuous mating system with internal fertilization, and so to copulate, a male must pull up directly behind the female in order to access her gonochore.